Okay, so hello and welcome back. So in this video we want to talk about exercise 14.5, which is some exercises related to basically about validating statements. Direct method, basically the method of contrapositive, contradiction, and so on and so forth, counter example, and so on and so forth. So it is exercise 14.5. So question number 1 is show that there is a statement and okay, so the statement that we have for question number 1 is if x is a real number such that x cubed plus 4x plus is equal to 0, then x is equal to 0 is true by okay, so if x belongs to the set of real numbers such that x cubed plus 4x is equal to 0, then x is equal to 0, then x is equal to 0 is true. So this is the statement that I have. If x belongs to the set of real numbers such that x basically satisfies this equation, then x is equal to 0. And well, of course we can test that. We can write this as x cubed plus 4x is equal to 0 and take an x out. X squared plus 4 is equal to 0. Either x is equal to 0 or x squared plus 4 is equal to 0. That gives us, so x is equal to 0 or x squared is equal to negative 4, which means that x is equal to plus or minus square root of negative 4, which is equal to plus or minus negative, actually 4i, right? 4i. Now these are not related to real numbers, but x is equal to 0 is basically a real number. So x is equal to 0 actually satisfies the equation. So what that means is that now you want to prove that this is true using the direct method. We need to go back and see what the direct method was. Okay, so in the direct method, we said that in order to prove the statement if P then Q, so if you have the statement if P then Q, in order to prove this statement, basically we introduced two different methods. Either we said that we could do it using the direct method. The direct method was basically we said that assuming that P is true, we prove that Q must be true. Prove that Q must be true. And there was another method that was called the contrapositive method. The contrapositive method. And the contrapositive method is by assuming that Q is false, by assuming that Q is false, then you prove that P must be false. Prove that P must be false. So that's basically the direct method and the contrapositive method. Now, in order to prove that, now this statement over here that we have, if basically x belongs to the set of real numbers such that if x cubed plus 4x is equal to 0, then x is equal to 0. That means that we have if x cubed plus 4x is equal to 0, then x is equal to 0. That's the statement that I have. Now, by assuming that P is, by using the direct method, by assuming that basically P is true, so P is true, that's the assumption that I make, which means that x cubed plus 4x is equal to 0. That gives me x is equal to 0 as we saw before. So then what you need to do here, the way to do it properly is, let me see. Okay, so now based on the direct method, let's take this, if x is a real number such that x cubed plus was equal to 0, then x is equal to 0. Then let's take this statement as P, and then let Q be x is a real number such that x cubed plus 4x is equal to okay, so then you can break this up. Let me clear this up, and then so if P is equal to this, then you can break it into Q and R, meaning that you can write Q as this is a compound statement, and then the component statements of this compound statement would be x is a real number, x belongs to the set of real numbers such that is a real number such that x cubed plus 4x is equal to 0, such that x cubed plus 4x is equal to 0, and R can be basically x is 0, x is equal to 0. So these are the component statements of this compound statement. Now, in order to, using the direct method to show that P is true, we have to assume that basically this part Q is true, and then show that basically R is true, right? So what I can do is that I can take, my assumption would be Q is true, meaning that basically x belonging to R, x cubed plus 4x is equal to 0, and then that would be x times x squared plus 4 is equal to 0, and then this will give you unreal roots, which is not what I'm looking for, because x belongs to the set of real numbers here. So that means that x is equal to 0 here, and x is equal to 0 is basically what I wanted to prove, is R basically. So that means that if I assume that Q is true, that means that this means that R is true. Now if Q is true, then R is true. That means that then P is true, because the way that we used in order to the method that we use, the direct method that we use in order to prove that P is true, is that we assume that P is true, and then using that we showed that basically R is true. So meaning that you assume that the if clause is basically true, and then you show that the then clause is true. That's basically what you do in the direct method. So now what I have done here is that I have assumed that Q is true, the if clause is true, and then what I have shown is that basically X is equal to 0, which is the same thing as R, and that basically means that P is true. P is true. Okay, so the next question that we have is, and of course there is something in the book that I need to point out to, and that is if you download the book for class 11, basically chapter 14 is basically the chapter that we are doing here, and these are 14.5, exercise 14.5. The answers to these exercises seem to be kind of misplaced. The answers are not related to these exercises, so you need to go somewhere else. For example, you can always go to, for example, these websites, like for example this. I think it's the best website that I have found ever since I started using these books, and that's called the tiwariacademy.com. and then if you go over here, if you go to home, you can find basically all of these free NCERT solutions for class 6, 7, 8, 9, 10, 11, and 12 for the subjects math, science, Hindi, physics, chemistry, biology, English, social science, and that's basically everything that there is, starting from class 6 all the way up to class 12. And of course mathematics is one of them, so you can go for these are the classes 6, 7, 8, 9, 10, 11, and 12. And so if you go to class, for example, 11 mathematics, then it gives you all of the chapters, all of the chapters one by one. For example, you can go for chapter 14, which is what we are doing here, mathematical reasoning solutions, and then you have 14.5, which is what we are doing now, and 14.5, for example, these are the solutions. So the question is, for example, show that the statement P is true by the direct method, method of contradiction, and method of contrapositive. And you get all of these solutions over here in the form of a PDF file that you can download to your computer as well. So, but of course you don't need to basically read all the solutions all the time, but there are times where these solutions come in really handy, because there are at times you will need to actually look up the solutions, because there are some things that you cannot do on your own. It's happened to me many times, really. And that's basically one way that you can solve your problems if you happen to have problems. Okay, so now using the contrapositive method for the same problem, what you need to do is that basically the statement was P if x is a real number, if x belongs to the set of real numbers, and such that x cubed plus 4x is equal to 0, then x is equal to 0. Now, using the contrapositive method, what you need to do is basically show that if assuming not q, you have to show not p, meaning that if q is not true, then p is not true. That's basically the contrapositive method. So what that means is that I'm going to assume that x is not equal to 0, meaning that q is not true. So assuming not q, meaning that I have to assume q is not true, meaning that x is not equal to 0, right? So let me see how they have got it here. I don't want to. So to show it to be true by contradiction, we assume that P is not true. Okay, so now basically what we need to do is, from the very beginning, by the contrapositive method, what we need to do is that by the contrapositive, or this is actually by the method of contradiction. So we want to show that the statement P is true by the method of contradiction. We want to show that statement P is true by the method of contradiction, and so for that we assume that P is not true. So by the method of contradiction, what you do, so what you want to do is you want to prove that basically the statement P is true. You want to prove that the statement P is true. When you want to use the method of contradiction, you have to use some sort of, contradiction. And the contradiction is that you assume that basically P is not true. That's the opposite of what you want to prove. You want to prove that P is true. So then you assume that P is not true because you want to use the method of contradiction. So now you can say that let x belong to the set of real numbers such that basically x cubed plus 4x is equal to 0, and let x not equal to 0. X is not equal to 0. So we want to basically, so what we have done here is that we have assumed that then basically if you basically break down this statement into two statements, you can write Q as, for example, x belongs to the set of real numbers such that x cubed plus 4x is equal to 0. And then the then clause you can write x is equal to 0. Now, in the method of contradiction, what we do is that we have to prove that if basically not R, if not R, then basically so basically if you show that if not R, then not basically not Q. Basically what we said over here is that, let me go to the method of contradiction. So then this method of contradiction is actually some sort of mixture of all the methods, because the method of contradiction, basically we said by the method of contradiction, we said that to check whether a statement P is true, we assume that P is not true. Okay? And so the method of contradiction, so for the method of contradiction, you basically to check whether, for example, whether some statement P is true, since you want to contradict, since you're using the method of contradiction, you assume that P is not true. That is not P is true, right? That is not P is true. That is not P is true. Now, if you want to show that, if you want to assume that not P is true, then you have to do, of course, the opposite of proving P. Now, when we want to prove that P is true, what we did, basically we had two different methods to prove that P is true. First we assumed that, which was basically called the direct method, we showed that P is true. We showed that assuming P is true, we prove that Q must be true. So assuming that P is true, we prove that Q must be true. Must be true. That was the direct method. Now, by the contrapositive method, what we did was that by assuming that Q is false, Q is false, then we prove that P must be false. Prove that P must be false. That is basically to prove that P is true, right? Now, if you want to show that P is not true, that is not P is true, so you can, for example, you can use the contrapositive method and assume that Q is false, and then if you assume that Q is false, then if you basically somehow get to the result that P is also false, then that means that P is true. Now, if you assume that Q is false and then somehow get to the result that P is actually true, then what that means is that the statement that you wanted to prove to be true is actually false. because by the contrapositive method you could not prove that it's true, right? So I repeat this in case you didn't understand me in this point, to just sum everything up. So you have some basically some statement P over here that you want to prove by the contradiction method. You want to prove that this statement is true by the contradiction method. Now, when you have some statement P, you can break it down into this is an if then basically statement. So an if then statement is a compound statement. So the compound statement, you can of course break it down into two component statements. I have broken it down to Q and R, meaning that I have written if x belongs to the set of real numbers such that basically this equation exists between basically satisfying x, then the statement R becomes x is equal to 0. X is equal to 0. So that's basically the statement that I want to prove to be true, and I want to use the method of contradiction. Now let's forget about this for now. Now, but in the method of contradiction, to check whether P is true, we assume that P is not true. Okay? We assume that P is not true, and then somehow get into some sort of contradiction which contradicts the assumption that we made, which basically somehow contradicts the assumption that we made, which was basically P is not true. So that means that if the result contradicts our assumption that P is not true, that means that then P is true. P is actually true. So what I'm going to assume is that basically not P is true, or P is not true. Now what you need to do now is that show that P is not true, or prove that P is not true. Now to prove that P is not true, there are two ways, as we saw before. There is the direct method and there is the contrapositive method. And these are actually for basically the way that we learned this was that these were actually for validating some statement. These were for validating these were for showing that some statement is true, but of course you can use them in order to show that some statement is not true or false. And what you can do now, what I want to do is that I want to prove that not P is true or P is not true, which means that I can use the direct method or I can use the contrapositive method in order to show that P is not true or P is false, or not P is true. So what I can do is that I could use the direct method. Now, assuming that P is true, if I prove that Q is true, that means that I have proved that P is true, which is not what I want to do. I want to prove that P is false. So then I could, for example, what I could do is that I could assume that P is true, and then prove that Q is not true, and that would basically prove that not P is true, right? Now I know that this is a little bit confusing, but bear with me, I will get you to the end of this discussion. Or I can use the contrapositive method. In the contrapositive method, by assuming that Q is false, if I show that P is also false, that means that then that statement is actually true. Now, if I assume that Q is false, but in spite of that P is not false or P is true, then that means that that statement is actually false. So I can do this exact thing over here. I can assume that Q is false, and then the result that I will get is that then P is actually true, which basically contradicts my assumption that not P is true. Then that means that P is true. Okay, so that's, I know it's a little bit confusing, but that's what you need to do, and that basically basically contains all the cases that you need. I mean, any sort of case that you might come across in this sort of basically proving business. So now again, basically the statement that I had was that if x belongs to the set of real numbers such that x cubed plus 4x is equal to 0, this is the statement that I want to prove to be true. And then of course x is equal to 0. Now I have broken this down into Q and R, the if clause and the then clause, and I've called them Q and R. Now in the method of contradiction, I have to check whether P is true, right? So in the method of contradiction, I assume that P is not true, and then basically I have to assume that P is not true, and then somehow show that P is actually true, meaning that the result will contradict my assumption, and that means that P is actually true. So now in order to show that P is not true, I will use the contrapositive method, meaning that I assume that Q is false, and then see what happens. So now what I can say here based on this whole discussion is that I can say basically let x be a real number such that basically the statement that we have, let x be a real number such that x cubed plus 4x is equal to 0, and basically let x not equal to 0. X is not equal to 0. The statement that I had was different. The statement that I had was basically this first part of this statement, that x be a real number such that this relationship exists, and x was actually equal to 0 there, right? Then x is equal to 0. That's what I wanted to prove. But then over here by the contrapositive method, I said that assuming that Q is false, meaning that x is not equal to 0, we want to prove that P is also false. Now let's see if we can do that. So if basically x cubed plus 4x is equal to 0 here, and if x is not equal to 0, so what that means is that x cubed plus 4x is equal to 0, which means that x times x plus 4x is equal to 0, plus 4 is equal to 0, or x times x squared plus 4 is equal to 0. Now, if x belongs to the set of real numbers, then either x is equal to 0 or basically x squared minus 4 is equal to 0. Now, since this will plus 4 is equal to 0. Now, since x squared plus 4 gives you unreal roots, that's not basically what we are looking for. We are looking for this root over here, which is a real number, which tells me that x is equal to 0. But here I assume that x is not equal to 0, which is a contradiction. So that means that the assumption that I made, which was basically the assumption that I made, which not P is true, is false. This assumption is false. What that means is that P is actually true, and that's basically how you use the method of contradiction. Therefore, P is true. Okay? It's a little bit messy, but when you understand the process, then it's not that messy after all, really. But, well, assuming that you don't understand the process, it could be a little bit confusing, of course. That I would admit to. Okay, so now let's prove by the method of contrapositive that the same statement is true. And your statement, our statement was, if x belongs to the set of real numbers, in basically such that x cubed plus, or I don't know what the statement was, x cubed plus 4x is equal to 0, then basically x is equal to 0. We want to prove this statement using the method of contrapositive. Using the method of contrapositive, what we do is that we have to show that if basically not Q, then not P. If that's true, then that means that this statement is true, otherwise it's false, right? So now I have to take this as Q, and I have to take this as P, meaning that I have to basically assume that I have to make an assumption that P is not true, right? So now let me see how they have done it exactly here. So in the solution, I have to be a little bit cautious, because I might say something which logically doesn't make, that doesn't make logical sense. That I have to be cautious here. So I go based on I just follow the solutions. So it says that to prove statement P to be true, if I call this a statement P to be true by contrapositive method, we assume that R is false and prove that Q must be false. So what they have done is that they have taken this as R. This part they have taken as R, and this part they have taken as Q, meaning that they have rewritten this as if Q then R. So what it says is that we assume that R is false and prove that Q must be false, meaning that the same thing that I said over here. We have to show that if not Q, meaning that if Q is false, then P is false, then not P. Now, here R is false implies that, or basically let me erase this because that doesn't go with Q and R. So here basically R is false. R is false implies that it is required to consider the negation of the statement R. So R is false, meaning that R is false implies that basically x is not equal to 0. That is, x is not equal to 0. Now it can be seen that basically meaning that if you write not R, that would be some statement like x is not equal to 0. X is not equal to 0 because x is equal to 0. Now it says that it can be seen that x squared plus 4, so here you have x cubed plus 4x is equal to 0. If I factorize an x, so I'll get x squared plus 4 is equal to 0. So here basically, where am I? Here, to obtain the following statement, it can be seen that x squared plus 4 will always be positive. Let me read the solution myself, I don't understand it. Okay, so I got the solution. Actually, it's a very interesting way of proving this. So what they have argued is that basically here it can be seen that x squared plus 4 is always positive. And of course it makes sense, because whatever the value of x is going to be squared plus 4, it's always going to be positive. And here we assume that x is not equal to 0. And this statement over here is actually the product of these two. Now if I consider the product of x and x squared plus 4, x times x squared plus 4, which is the same thing as x cubed plus 4x, which is this thing over here. So here I have x not equal to 0, some non-zero real number, and a positive real number. Here we said that x squared plus 4 is a positive real number. So the product of a non-zero real number and a positive real number is always not equal to 0. Which means that, which shows that basically the statement Q is not true, because Q says that x cubed plus 4x, which is the same expression as this, it says that that is equal to 0. And here we have shown that this thing cannot be equal to 0. So that means that basically not Q. Basically that means that Q is true. That means that not Q is false. If I say basically not Q, which is basically Q is x cubed plus 4x, if I take that to be true, then this means that so if I take this to be true, then that means that not Q is actually true here, right? So that means that basically if I assume that R is false, then Q is going to be false, which means that basically not R implies not Q, which is the method of contrapositive, right? So that means that based on the method of contrapositive, we have shown that not R implies not Q. Therefore, the given statement is actually this statement is actually true. So, in case you didn't understand this, so in the method of contrapositive, you have to break down your statement into two component statements. Let's say, for example, Q and R. I have here I have taken R as the then clause and Q as the if clause, right? So in the method of contrapositive, we show that not R implies not Q. We have to show this. We assume that R is not true, and then based on that we show that Q is not true. If that's the case, then that means that the statement that we started with was actually true, and that's based on all the other concepts we talked about prior to this video. So of course I cannot go back there, but hopefully you understand why that is. So long story short, based on the method of contrapositive, you basically take R as false, and then based on that you want to show that basically not R implies not Q. If you can do that, then that means that this statement over here is true, otherwise it's false, right? So, and that's basically what we have done over here. Okay, so that was one example which took a whole lot of time to do, but it takes a little bit of time in the beginning to get yourself familiar with basically the different bits and pieces of basically these different things working together. Now, question number 2. You want to show that the statement for any real number a and b, for any real number a and b, a squared is equal to b squared, a squared is equal to b squared implies that a is equal to b. Implies that a is equal to b. Is not true by giving a counter example. You want to show that this statement is not true by the method of counter example. So by the method of counter example, let's see. Okay, so now for this example, it says that for any real number a and b, a squared is equal to b squared implies a is equal to b. Meaning that, for example, now the counter example that you can, for example, and you want to prove that this is not true, by the method of counter example. So for example, if a is equal to b, for example, let's say if a is equal to b, if you have a squared is equal to b squared, for example, let's say 9, for example, nine is the same thing as negative 3 squared, and also 9 is equal to positive 3 squared. So you can take your a as negative 3 and your b as positive 3. You can take your a as negative 3 and b and positive 3, and then based on this your a squared is equal to 9 and b squared is equal to 9, but a squared is equal to b squared, but now a is actually not equal to b. A is equal to negative 3 and b is equal to positive 3. So this is, for example, one counter example that you can provide here. And of course you have to do it in a systematic way, meaning that otherwise you might make a logical mistake, meaning that basically you can write this in the form of an if-then statement. So you could write basically if a and b belong to the set of real numbers and a squared is equal to b squared, then a is equal to b. right? So that means that this implies this. Or you can, that's basically how you can write it. Now, if now the way that you can show that you can basically work through this example logically and write is that so I write my expression or my statement as if a and b are real numbers, such that a squared is equal to b squared, then a is equal to b. Now you can say that, for example, let P be the statement a and b are real numbers. A and b belong to the set of real numbers, such that a squared is equal to b squared. Such that a squared is equal to b squared. So that was basically that was P, and let Q be equal to, let Q be the statement A is equal to B, right? So that is basically your statement now. Now the given statement has to be proved false. You want to prove that this statement is false. For this purpose, it has to be proved that if P then not Q, if P then not Q, meaning that if P not Q, let me see. Okay, so in the direct method, there were basically two cases. In the if then statements, we had two cases. We had the direct method and the contrapositive method. So in the direct method, we said that we assume that P is true, and then we prove that Q must be true. So assume that P is true, and then prove that Q must be true. So that means that then P then Q is true. Now in order to prove that P then Q, basically to prove that P then Q is false, instead of, now I can make it the same assumption that P is true. Assume that P is true, and then prove that Q is false. So normally to prove that, so this is to prove that basically P then Q is false. Now normally in the direct method, what you do in order to prove that P then Q is true, so what you do is assume that P is true, and then prove that Q is true, right? So that is basically to prove that P then Q is true. Now to prove that P then Q is false, so you make the same assumption that P is true, and then you prove that Q is false. Okay? So we can do the same thing over here. Now if I assume that P is true, that means that basically A and B belong to the set of real numbers, and A squared is equal to B squared. A squared is equal to B squared. Meaning that I want to show that if P then not Q. Okay, I want to show this. Now, for this purpose, it has to be proved that if, okay, so to show this, two real numbers a and b with a squared is equal to b squared are required such that a is not equal to b. So for this purpose, basically to show this, two real numbers a and b, two real numbers a and b with a squared is equal to b squared, with a squared is equal to b squared, are required such that a is not equal to b, such that a is not equal to b. Okay, now let a be equal to 1 and b equal to -1, the same example that I used over here. I got over here a -3 and b +3. You can take it as -2 +2, -1 +1, and so on and so forth. So now let a is equal to 1, let a is equal to 1 and b be equal to -1. Then a squared is equal to 1 squared is equal to 1. A squared is equal to 1 squared is equal to 1. And b squared is equal to -1 squared is equal to 1. That means that basically a squared is equal to b squared, right? And that is basically p. So p is true. P is true, but q is not true because a is equal to 1 and b is equal to -1, meaning that a is not equal to b, right? So based on that, it can be concluded that the statement that we started with here, is actually false. That's the method of counterexample. Now, of course, I did it over here not in a logical way. Now, of course, it was logical, but the problem with this method is that if there is something wrong with your logic, you will not be able to see it, and you can very easily make logical mistakes. But when you write everything down step by step, then there is no room for making mistakes, meaning that, for example, here you write, let P be, for example, A and B belonging to R such that, for example, A is equal to B squared and A is equal to B, and then of course you need to know how you want to do it. So in order to prove that P then Q is false, in order to prove that P then Q is false, you need to assume that P is true, and then prove that Q is false, and then you will do the same thing over here, meaning that you want to show if P then not Q, the same thing that we have said here. Now, to show this using the method of counterexample, what we do here is that to show this, two real numbers a and b with a squared is equal to b squared are required such that a is not equal to b. And then you can pick any two real numbers, for example, -1, +1, -1, -2, +2, -3, +3, because those numbers are going to be squared. And when you square these two numbers, you're going to get the same numbers. When you square -2 and +2, in both cases you're going to get a +4, and so on and so forth. So then if a is equal to 1, b is equal to -1, then of course a squared is equal to b squared. But then a is not equal to b. So that shows that basically p is true, and so you have basically shown that if p, then not q. And that shows that your statement, which was this thing over here, is actually false, meaning that you have proved that the statement was false. This way you need to solve these problems, not the way that I did it in the beginning, that I actually don't approve of. You would make logical mistakes. So the next question that we have here, we have a couple more questions. We will go through them as well. So in the next video we will talk about example number 3. I'll see you in the next video.